6.2, definite integrals. So these are honestly quite easy, and they're like fun. So remember when we did antiderivatives back, I don't even know when that was. Yeah, I was gonna say like early 5.2, I think, or very end of chapter 4. Anyways, basically we did antiderivatives. So now we'll be taking the antiderivative and evaluating it from like point A to point B, basically is what it is. So the first thing though in here, when I can get to the right page, says which the instruction sounds super confusing, and it's actually not really confusing, but each C sub k is chosen from the kth subinterval of a regular partition of the indicated interval into n subintervals of length delta x. Express the limit as a definite integral. So,
I hate the word limit.
well, we're not actually doing limits, so it's just what they look like to start with. So number 2, we've got the limit as n approaches infinity of the sum of k equals 1 to n. Something wrong?
No.
Just number 2.
Oh.
It's
Yep.
really tickling his fancy today.
So c sub k squared minus 3c sub k delta x. And it's on the interval from -7 to 5.
So does k always equal 1? At least for these.
For the most part, it'll be k equals 1 to something. When you get to Calc 2, which is when you do a lot with summations, that's not always the case, but it just depends.
So is the summation sign like a letter, like one of those Greek letters?
Probably. I mean, technically, yes. I guess it's technically speaking, it's a capital sigma, I think.
I thought.
And I always just write it like this, but technically it's like,
I just draw like a backwards 3.
Yeah.
Just call it a day.
like in the book, it actually looks like a sideways M.
Yeah.
So,
I always draw like a funky E.
yeah. So we've got the integral from,
All S.
it's pretty much what it is, from the first thing to the second thing, so -7 to 5 of x squared minus 3x dx. And that's it. I can tell Virginia likes this better than what we were doing.
I'll take anything else. But all I'm saying, me studying for that
So
test
that's
the night before.
that's all that the answer is? Okay.
Trying to pick the right color to draw this in. I was being indecisive.
So 6, the limit as n approaches infinity of the sum of k equals 1 to n of sine cubed of c sub k delta x for the interval -pi to pi. So we have the integral from -pi to pi of sine cubed of x dx.
What happens to my water bottle? It's not making the sound anymore.
Depends on how much water's in it.
Huh?
The amount of water in it makes a difference.
Right, but it still makes a sound even without as much water.
It also usually is more if you hit it against something like metal versus like your hand.
Right, but it always used to work. There we go.
It's like a tuning fork.
Okay, it's still wonky, but it's okay.
I remember being in the computer lab one time when Sarah and Melcher were doing tuning forks and like doing stuff with the cow. Like I specifically remember that. And I was like, what is it doing
Yeah.
there?
I love how you sometimes call your sister Syrup.
It's just I gotta fast forward.
Just gotta get it out quick.
Yeah, I gotta get it. It's too much.
All right, number 8. Evaluate the integral from 3 to 7 of negative 20 dx.
So do we throw it into the limit thing?
No,
Oh, dookie.
we don't use limits to do these.
Oh.
So we take the antiderivative of negative 20 dx, which would be what? Throwing it back to see if you remember.
And what's the
So that's like
antiderivative
negative.
again?
So the negative 20 thing would be negative 20x.
Yep. The antiderivative undoes this, so.
Okay.
Then this gets evaluated because this is a definite integral from 3 to 7.
Is that what that line means?
Yes. I made it kind of excessively long. It's not normally that big, but minor details. So this would be, it's always evaluated from the top minus the bottom. So negative 20 times 7
I know that thing wasn't in the notes.
minus what?
That line thing wasn't in the notes.
Well, I don't think I did an example in the notes for you, did I?
No, but you did show us the tall S thing though.
Well, yeah, because you have to know what that is. Plus, we'll also have indefinite integrals later that don't have numbers on them, so. So then minus negative 20 times 3. So that ends up being negative 140 plus 60, which is equal to negative 80, and that's the answer to that. But I already solved that.
Love that.
And just to be clear, whatever this variable is here, like the d whatever, is telling you what variable we're doing it with respect to. So that should always be the variable that gets used when you do it down here, which will come into play in problem 10, which is the integral from negative 4 to negative 1 of pi over 2 d theta. So what's the antiderivative of pi over 2 d theta? Pi over 2 theta. Evaluated from negative 4 to negative 1. So we've got pi over 2 times negative 1 minus pi over 2 times negative 4. Which is negative pi over 2 plus 4 pi over 2, which is 3 pi over 2, and that's your answer.
How do you get the antiderivative?
So we just basically, so like when you take the derivative, we take the exponent, we throw it out front, and then we take one away from the exponent, right? So this is doing the opposite. This is technically taking something from in front and putting it up top, but in this case it's just a 1 because there's no variable there. So like this next one, it'll be a little easier to see what I'm talking about because it actually has a variable already in it. So, oh, well, this is a slightly different kind of problem, but I still work it the same way. 14, the integral from 1/2 to 3/2 of negative 2x plus 4 dx. So we take each piece as like the antiderivative like of itself. So what power is on the negative 2x right now? 1. So I need to add 1 to it. So this is the way I will often do it. So I'll say, okay, this has got to be x squared. So if I take the derivative of this, it would give me 2x. So what still has to be in front of it? A negative. So once you find your antiderivative, you can take the derivative of that number or of that piece. So if I take the derivative, this would be negative 2x. And I know that I'm back to where I'm supposed to be. So I always will throw the exponent up here first. And then I'll figure out, okay, what do I need to do in terms of what's in front of it so that if I take the derivative, I get to what this was to begin with.
So whatever even if that was like negative 2x squared, we would start with x cubed
And then it would be negative
Take the
2/3
derivative.
x cubed. Because we're basically dividing whatever's in front by the number up here,
Okay.
essentially. So then the plus 4 would just be plus 4x because I had essentially x to the 0. So to give it x to the 1, it has to be this. Ooh, what is this?
Strawberry popcorn.
Is this homemade popcorn?
No. Store-bought. But
Oh, I was
tried-
like, geez,
I
y'all are
tried-
getting really creative.
I've tried it once, and if you don't like it, don't blame me.
It looks yummy, thank you.
Y'all want one? I'll let y'all.
Huh?
One.
I got one from her yesterday.
I'm good. I'll pass. Ah.
Oh, too late. You already have one.
I got one yesterday, Josh.
Can't fall through the bag, you take it.
You're the one who took it.
That's because he threw it at me.
Stop throwing it at me. I already have one. Stop.
All right, so now we evaluate this
Popcorn.
It's yours. Stop. Stop.
from 1/2 to 3/2. So we have to look at this though piece by piece. So I will often use a bracket when I start doing these because it's each of these things evaluated at 3/2 minus each of these things evaluated at 1/2. So this is going to be negative 3/2 squared plus 4 times 3/2 minus the bracket negative 1/2 squared plus 4 times 1/2. So this is negative 9/4 plus, I'm deciding if I want to go ahead and simplify this or not. No, I'm going to leave it as 12/2 minus negative 1/4 plus 4/2. Oh, I think I can't simplify this because I think these come out to nice numbers. So negative 9/4 plus 1/4 would be what? Negative 8/4. Then 2/12 minus 4/12 would be 8. Why did I say over 12? 12/2 minus 4/2 would be 8/2, which is 4. So this is plus 4. So this is negative 2 plus 4 is 2. So that's your answer. Now, I'm going to be nice and show you the trick to do these. I don't normally show this right away. So you can actually do integrals in your calculator also. And, well, specifically definite integrals. Indefinite don't really work. So math, and then arrow up to FNINT. So then we put in 1/2, 3/2. Then negative x squared plus 4x dx. Now, obviously, if the variable is something other than x, your calculator really only uses x in the form, like the function form that we're in, so just use an x and then just know that it's not x when you actually do the problem. But if I do that, why did it do that? Did I type something in wrong? Oh, yes I did. Y'all know what I typed in wrong.
Yeah.
I typed in this bottom part. That's what happens when I'm only slightly paying attention while I do this.
I trusted you.
I know. I led you astray.
Yes, you did. I can't believe you. How dare you?
Equals 2. There we go. Let's see.
I think my water bottle's still malfunctioning. What are you doing with your fingers?
Huh? I don't know.
All right.
What does this mean?
I don't know. I was just.
Okay, I think it's good now.
All right, so the next things they say use the graph of the integrand in areas to evaluate the integral, which is kind of just like a weird way to do this, but the reason they're doing it this way is because you don't yet know how to solve these, but by the time you take the quiz, you will know how to solve these, so just bear with me for what we're doing. So we have the integral from -1 to 1 of 1 plus the square root of 1 minus x squared dx. So this one, in theory, if you graphed this, it would be essentially a rectangle with a semicircle. Josh doesn't believe me, so he's gonna check
It's
it.
not that. I just need to see this because that sounds hilarious. You know? Like, how do you end up looking like that? Oh, that's not it. That can't be it.
Is that what I said?
There's no rectangle.
Well, it's not actually a rectangle.
Yeah.
It's like
It really only has a semicircle part.
I see a little dot under the semicircle.
but it technically like flattens out a little bit.
Yeah. It's like.
All right, so what's the equation of a circle?
Like
H
x
K
minus, I'm gonna say h.
Okay, not that form. The generic form of a circle.
X squared plus y squared equals r squared.
Yes. Okay, so if I move the x over, I would have y squared equals r squared minus x squared. Take the square root. Y equals the square root of r squared minus x squared. Well, what does that kind of look like?
Thing.
What we had there.
Yeah, with a radius of 1. So that's my semicircle part. So first of all, I'm looking at the rectangle piece, which is length times width. Which in this particular case is just 2 times 1. Because from -1 to 1, that's 2 times 1 is 2.
So where's the one coming from? Okay.
Then the semicircle
Oh, I just wrote it equals 0 instead of 2.
is like this. Well, what's the area of a circle?
You got this, Virginia.
Pi r squared.
So what's the area of the semicircle?
Pi r squared divided by 2.
Yeah.
Yay.
Or 1/2 pi r squared. Radius is 1. So 1/2 times pi times 1 squared is just pi over 2. So the total area is 2 plus pi over 2.
Wait, where'd the 1/2 come from?
So that's a semicircle.
Oh. Okay. I wasn't.
Again, don't stress over this too much because ultimately you will learn how to take the antiderivative of that and then you just won't even have to worry about it.
Sounds good to me.
But I usually show one of these just so that you've seen it because, yeah. All right. Back to how we were doing them. 22. The integral from root 2 to 5 root 2 of r dr.
RDR.
So what would the antiderivative of this be?
1/2 r squared.
So it's r squared would be the exponent, but if I put the 2 in front, that doesn't give you what I had when I take the derivative. But if I have a 1/2 here, when I multiply this, I get a 1 in front.
Oh, that makes sense.
Evaluated from root 2 to 5 root 2. So when you have a number, like a whole number out here in front, like the 1/2, I can just do 1/2 times my whole thing instead of having to write it every time.
That's brilliant.
So we've got 1/2 times 5 root 2 squared minus root 2 squared. So this is 1/2 times 25 times 2 is 50 minus 4, nope, 2. So that's 48 divided by 2, which is 24.
Oh.
Yeah, it's crooked. Don't judge.
I mean, it makes the 24 look crooked too, so it's a little less odd. But I don't think that was the intent.
It was not. Alright, these again say use areas to evaluate the integral, but we don't need to use areas because we can just evaluate the integral. Oh, no, 26. Integral from a to b of 3t dt. 0 is less than a is less than b.
3D
3t dt. Not 3d dt.
3D. That was fun. No, hold on, I need to get a paper out.
Josh is like, you need to hold or right now.
Yes, ma'am. I had to pull out my paper folder for that.
I wonder if, I'm trying to think of what this thing would be. Takes me a second.
3/2 t squared.
Well, I was about to say that.
I'm so proud of you.
Well, you didn't give me the chance to shine.
Well, your hands are so dry, I don't think anything can shine.
You got the next one. I know you got the next one.
Oh yeah. Okay. Hear
Hold
that,
on.
Josh?
So 3/2 t squared evaluated from A to B would be 3/2 times B squared minus A squared. And that's it. And I guess since I'm not doing anything else, I could have just made these parentheses. It doesn't really matter, but
Yeah. Anything in those brackets. Much effort to erase everything.
$28. The integral from A to A root 3, or they technically do root 3A, but I like the A in front because then it doesn't look like it's under the radical also. Of x dx, A is greater than 0. All right, Virginia's got this one. I believe in her.
Alright, let's see.
It's taking you too long.
Let me think. Would it be 1/2 x squared? Yes.
Took you so long.
Well, it takes me. It's a.
Just
It
write
doesn't
down the
click
x
for me.
squared and then look at it.
Typically, whatever your power is, it's going to end up being divided by that number. Not 100% of the time, obviously, but a lot of the time that will be the case.
Okay.
So
She
1/2.
literally showed you how to do
Well, I
that.
know, but it didn't click the first time. I just said
Well,
that
it
it
is
did
better
because I
click
was,
now.
embarrassed.
It's just me and Stacy. There's nothing to be embarrassed
And
about.
the people watching.
All 12 viewers. I mean,
Even
followers.
Me watching like 12 times. That one.
Subscribe to my channel, hit the little bell.
Turn post notifications.
So we got 1/2 times A root 3 squared minus A squared, which is just 1/2 times 3A squared minus A squared, which is 1/2 times 2A squared, or just A squared.
That one was nice. Okay, we should resolve to get to 1/2 x squared. I could tell.
All right, some word problems using theorem 2. Find the output from a pump producing 25 gallons per minute during the first hour of operation. What do you notice about this? Other than that it's a word problem.
It's making me think of those torture problems we had at the end of last chapter.
Sort of. But what about the units?
Gallons per minute.
And it needs in hours. Maybe.
So potentially, but I would say maybe go to minutes instead. They want it during the first hour, which would be 60 minutes, right? So we set this up. It's the integral. So during the first hour is like everything that's occurring in that time. So from 0 to 60 minutes would be the 1 hour of 25 dt.
25 dt.
So what's the antiderivative?
T.
I mean T. I mean T.
How dare you?
25t evaluated from 0 to 60.
Can't believe you.
So this would just be essentially 25 times 60 minus 0, which I don't really need the minus 0, but
Can we put an equal sign in between the line 0, 60 thing and then like the other stuff? Or are we not supposed to put an equal sign between those?
I mean, you can. I don't.
Are they technically equal though?
Well, this is like the equal sign because this is saying evaluated at this, so it's not really equal. So this is 1,500 gallons. Did you hear that?
Yes.
Okay.
So I was just about to say we like low key could have just done conversions and solved it. But for the purpose of the section, we have to
Yes.
use the tangible thing.
Well, and it says express the desired quantity as a definite integral and evaluate the integral using theorem 2, which this is theorem 2. So technically I could have just done, I think what theorem 2 actually says. Let me find it. Did we even write down theorem 2?
I remember
Yeah.
writing it down. Is it the integral of a constant?
I don't know if you had it because it might not be on this paper. Theorem 2 just basically says, so what I should have written technically to use theorem 2 here is just, we take this number, which is just 25 times 60 minus 0. So essentially, I just didn't need this part to officially use the theorem. But it's not the end of the world if you do it. We'll just do the next one using theorem 2 only and not the other thing. So 32. Find the amount of water lost from a bucket leaking 0.4 liters per hour between 8:30 a.m. and 11 a.m.
How many liters is that? 0.4?
0.4. So obviously I can't just put time in my integral, but I know that 30 minutes is what of an hour. So what I can do is I can do the integral from 8.5 to 11 of 0.4 dt. And then technically using the theorem here, I would have 0.4 times 11 minus 8.5. And that's 1 liter. Now the very last thing is using the NINT function on your calculator to solve 3 plus 2 times the integral of 0 to pi over 3 of the tangent of x dx. Now, you could not do this yet, but again, eventually we would be able to figure this out, well, sort of, by hand. So we hit math, and then our calculator says FNINT. The book just says NINT, but this is what this means. So we do 3 plus 2, then math. The integral from 0 to pi over 3, and I just realized I'm probably in degree mode, which I need to be in radians. Anytime you're doing this stuff, obviously you should be in radians unless it says otherwise, but
I got it.
that would be 4.39. Alright, problems.
Is that all for the section?
Yep. 1, 5, 9, 13. 15 is another semicircle. 25, 31, and 33.
Which one's the semicircle?
15.